Hey everyone, in the last lecture we talked about how to apply the area to the left of a z-score. In this lecture we're going to be talking about how to do that but backwards. In this case, I'm going to give you the area to the left and you're going to apply this concept backwards. So let's get started. Alright, again, we're going to go over to the computer and we're going to work through an example together. I'll see you there. Alright, so just like in the last lecture, the way this is going to work is I'm going to set up this problem and then I'm going to have you guys pause it, and then we're going to go over the solution. Now, keep in mind that this is technically a word problem, but I'm not going to throw a bunch of words at you. I'm actually going to set up this problem visually with you guys, especially for those visual learners who like to, instead of reading a bunch of words, they can see the math in front of them. So here I have the IQ bell curve. Now, this bell curve has an average of 100 and a standard deviation of 16. Now, in the last lecture, we talked about how to find the area to the left of a certain IQ score. So you would first convert that IQ score into a z-score, and then you would find the area to the left of that z-score. Now we're going to do everything a little bit backwards here. So the idea is I'm going to set up this problem. I'm going to put a little mark right here and a question mark. This time, the goal of this problem is to find an IQ score. So you're going to tell me what this IQ score in this question mark is. And let me tell you the only bit of information that you know about this IQ score. The area to the left is going to be 0.7794. So that's all you know. The area to the left of this IQ score is 0.7794. Now, let's try to solve this. Before we solve it though, pause the video and then we'll get into the solution. Alright, so again, we've never really mastered the IQ bell curve, and we never will because we don't have a chart that tells us the area to the left of certain IQ scores. We have mastered the standard normal distribution. And so let me redraw the standard normal distribution here. That's my attempt at the standard normal distribution. And this number is, in the middle, is 0. So I have an average of 0 and a standard deviation of 1. Now, I want to find the corresponding z-score that corresponds with that IQ right there. So I want to know what this z-score is. So I actually don't know what that z-score is. There's kind of a problem here. Well, in the last lecture, let's try something that a lot of students do. In the last lecture, we talked about converting from IQ to z-score. So what if we try to use like this formula here, z equals x minus mu over sigma. If we want to find this IQ score, then that would be finding x. Well, we know mu, we know sigma, that's good, but we don't know z. We don't know what the z-score is. So we can't quite do that. Maybe we can figure out what the z-score is. So we would just do x minus mu over sigma. Problem is this x, we don't know what that IQ score is. So there's no way to figure out what that z-score is. We don't know what that is. That's a huge problem. But we do know the area to the left of the z-score. And I'm going to explain why in a second here, but I'm going to draw this region for now. This region should be 0.7794. Because remember that if this IQ score corresponds with that z-score, if those two numbers actually correspond, then the properties should be the same, meaning the area to the left should be the same. So I know the area to the left of this z-score that corresponds to that IQ score is 0.7794. So that's actually going to help me find that z-score right there. So we're going to try to figure out what that z-score is first. Now, in this problem, we're given the area to the left of a z-score and we're asked to find the z-score. We've done this problem exactly in the past. So if you haven't checked that out already, make sure you look at the videos of mastering the z-score bell curve or the standard normal distribution. So what I'm going to do is I'm going to go over to my z chart and I'm going to look for this number in the areas section because I'm given an area and I'm trying to find the z-score. And I'm going to explain why that's really important to frame it that way. So let's go over to our chart real quick. Now I'm going to pull up my annotations so that you guys can see my markings on the screen. So it's important to understand that these numbers right here, all of these numbers in this middle section here, are areas to the left. And these numbers right here on the outside edge represent z-scores. So it's important to understand that in this case, we're given the area to the left and we're trying to find the z-score. So we're told that the area to the left is 0.7794. Which is right here. So that is my area to the left. Now it's important to understand that we can't really look for 0.7794 in the z-scores because 0.7794 represents something. We can't just look at that number and say, oh, it's a z-score, or oh, it's an area, because that actually really matters. We have to understand and conceptualize what it represents. So in this case, it represents a probability. So this is my probability, 0.7794. What z-score corresponds to that probability? And the answer is 0.77, it looks like. 0.77 corresponds to an area to the left of 0.7794. And yeah, they're both 0.77. That is completely coincidental. It's very rare that sort of thing happens. All right, so 0.77 is my z-score. So let's go back real quick to our bell curves. And let me explain what we just found. We just found that this z-score right here is 0.77. So we know what that z-score is. It's 0.77. I'm going to write that underneath there. So are we done with the problem? Did we answer the question? Well, no. We're trying to figure out what goes in that question mark. But we're getting a lot closer, especially since now we know the corresponding z-score. And if you remember, there is a formula that we were talking about earlier, x minus mu over sigma. Now we know mu, it's 100. We know sigma, it's 16. And now we have the corresponding z-score, which is 0.77. So now we can figure out what x is, which is our corresponding variable, the number of interest, our IQ of interest. So let's see here. Z is 0.77 equals x, my unknown, I'm trying to figure out what that is, minus my average, which is 100, divided by 16. So now we need to solve for 0.77. And this requires a little bit of algebra, but it's not too bad. I'm going to multiply 16 on both sides. And if you're struggling with this, I recommend like a basic math course. Maybe check out some textbooks on elementary algebra, and this will help you with these steps. So 16 times 0.77, I'm going to look at that real quick on my calculator. 12.32. So 12.32 equals x minus 100. So now we just add 100 to both sides. And I'm going to real quickly rewrite this 12. Well, I don't want to delete anything. I'm going to add 100 on both sides. And then I'm going to write my solution. There we go. I'm going to write my solution over here. So 112.32 is on the left side there. And on the right side, these two cancel each other, and I'm left with just x. So my answer is 112.32. So that number is 112.32. That corresponds with a z-score of 0.77, which has an area to the left of 0.7794. Therefore, the area to the left of 112.32 is also 0.7794. So as you can tell, these problems can get relatively tricky at first, but it's really important to understand that we need to master this standard normal distribution. If you haven't done so already, make sure you check out those lectures again and again and again. Do the example problems. They'll help a lot. Thank you guys so much, and I'll see you in the next video.